Okay, so 6-4, rationalizing to find the limits. So we're going to continue working with our limits. Again, the first step in doing any limit problem is to take and do direct substitution to see if you can find the limits that way. So we're plugging the 3 squared minus 9 over root 3 minus root 3. And hopefully you see 3 squared is 9, minus 9 is 0, root 3 over root 3 is 0. So method 1 is not going to work, so we're going to method number 2. Okay, so we have x squared minus 9. Should see that as difference of squares, so x minus 3 and x plus 3. And then the denominator have radical x minus radical 3. So in order to simplify this, we have to rationalize the denominator. We can't leave those radicals. So this is going back into a really long time ago in your past. But thinking about how do we get rid of the radicals, I do think we touched upon this at the beginning of the semester, but as a refresher, to get rid of the radicals, if you multiply by what we call the conjugate, same terms, opposite sign. So radical x minus 3, radical x plus 3, and we're going to do that, whatever we do to the denominator, we do to the numerator. On the bottom, when we distribute this out, we get radical x times radical x. It gets rid of the radical and just gives me x. And on the top, and then if we do radical negative 3, negative radical 3 times radical 3, we get negative radical 9. Because it's opposite signs, the middle two terms would cancel, which is why I skipped the middle two terms, okay? So then if we simplify that, we get x minus 3. So we rationalize our denominator. Our numerator, when we multiply this out, we're just going to write it all out. We're not going to actually multiply. So we got x minus 3, x plus 3, and then we've got radical x plus radical 3. Okay? And then we should see that the x minus 3 cancels. So now when we plug 3 in, we won't get a 0 in our denominator because we eliminated the denominator. So that is our goal. We can't have that radical in the denominator. When we plug in 3, we can't get a 0. So we have to simplify till we get rid of that. So there's the denominator is gone. So we have x plus 3 times root x plus root 3. And now we're going to do our substitution. So we're going to plug in the x equals 3, and we get 3 plus 3 times root 3 plus root 3. 3 plus 3 is 6. Root 3 plus root 3 is 2 root 3. And if we multiply those together, we get 12 root 3. So that is the answer. All right. So again, you need to make sure we don't get 0 in the denominator because then we can't solve. So we have to get rid of the denominator. To get rid of the denominator, we rationalize the denominator and simplified. And then you see this cancels and the denominator is gone. What's left is where we substitute. So now let's look at the next one. Similar idea. If we plug in 7, oops, sorry, my highlighters just rolled. If we plug in 7, we get 7 plus 2 minus 3 over 7 minus 7. Square root of 9 is 3 minus 3 is 0 over 0. So we go to method 2. So now we're going to write down our radical, x plus 2 minus 3 over x minus 7. And again, if we plug in the 7, we're going to have 0 in our denominator. So we've got to work this problem out. So to work this problem out, we're going to rationalize our numerator this time because the radical's on the top. So same idea, we write the exact same terms with the opposite sign. The reason why we do that is always with the opposite sign, our middle terms will cancel and it will get rid of the radical. So if we simplify this on the top, we do the radicals together and we end up with just x plus 2. And then we do our whole numbers, we end up with minus 9. And on the bottom we have x minus 7 times x plus 2 radical plus 3. And then if we simplify our top, hopefully we notice we get x minus 7. So this cancels, we have x minus 7, and then you can see the x minus 7 is going to cancel with the x minus 7, leaving a 1 on top. Remember, if everything cancels, a 1 left, over root x plus 2 plus 3. Notice the 7, the x minus 7 is no longer on the bottom, so when we plug in our 7, we don't have to worry about getting 0. Okay, and then if we simplify that, we're going to substitute at this point. X equals 7. So we have 1 over 7 plus 2 radical plus 3. which would be 1 over the square root of 9, which is 3 plus 3, 1 over 6. So wherever your radical is, that's one you have to rationalize, okay? Sorry about going off the page. So if it's on the top, you're going to rationalize the numerator. If it's on the bottom, you do the denominator. By doing so, it's going to help you make it so the denominator is no longer 0. So you're going to see some problems like this on the worksheet. Watch and follow them very carefully. The second part of this lesson gets into what happens when we have trig units. Okay, so the limits using sine. And I kind of put diagrams in here so we could see the idea better. So the limit as the angle approaches 0 when you have sine of theta over theta. I graph sine of theta over theta. As we approach 0, so that would be heading towards here from both directions. What is the graph approaching? It's approaching 1. So we have equals 1. As we approach, do the same thing as we approach infinity. So that would be going this way. As we approach positive infinity, where the graph is actually heading towards 0. It's going to curve around. It's heading towards 0. So these are rules that we're going to help us simplify when we go to do the problems. So as we go towards 0 or as we go towards infinity. And then here, if we have theta over the angle over sine, so this is basically the reciprocal of this one, it still gives us 1. If we watch our graph as we head towards 0 from both directions, we're still heading towards 1. Okay, so I just put those graphs in there to kind of give you a visual of what was going on. So for this problem here, we have sine 2x over x, okay, and we want to know the limit as we're approaching 0. So if we look up here, we have sine 2x over x. The rule says sine x over x because we can replace theta. It's a variable. So we need sine x over x in order to simplify this. But right now we have 2x. So if we want to do sine x over x and we have 2x, what do we need to do to make this simplified? Okay. And again, we should have plugged in 0 first, but we got 0 over 0, so we can see that that doesn't work. So if we take sine x over x and multiply by 2, okay, over 2, we get sine 2x over 2x. Okay. Then, so we multiplied by 2. Does everybody follow that? And so this gets multiplied by 2 over 1. And if we do that, this term is 1 because it's the same thing top and bottom. Okay. And if we would do the 2, these 2's would cancel. Does that make sense? So then the same thing top and bottom times 2, because this is 2, equals 2. So we're trying to make, we have 2x. In order to get the 2x, we need to multiply. Let me just go through that one more time in a little different explanation, I think, to make sure we're clear. In order to get the 2x on the bottom, we need to multiply the bottom by 2. All right? And if we multiply the bottom by 2, that means we multiply the top by 2. I'm going to bring this 2 over here and write it as sine 2x over 2x. That means the 2 is still here, but there's a 1 on the bottom. So I just already multiplied here. These are the same now, so that's equal to 1 times 2, which is 2. Sorry, the first way through I was trying to explain it, but I didn't think it was as clear. So 2 different ways to look at it, but the idea is once you have the same thing top and bottom, it's equal to 1. So we're working with that multiplying by 2 on the bottom to get them to match. Whatever we do the bottom, we do the top. So that 2 has to be existing, so it's 2. So now let's look at this one. We have sine 2x over 4x. So we're going to have sine 2x. If we want to put 2x on the bottom so that we know they match, then we'd have to multiply this bottom by 2. Because that would give us sine 2x times 2, right? This would make the 4. So this would be equivalent to that. This part here equals 1. This would be 1/2. So the answer would be 1/2. Okay, so we're just rewriting this expression so that we can make sure the top and bottom are the same. And then that becomes 1, that's the half, and we've solved. Okay, so I can put another one on here if you just want to see the idea again. Limit as x approaches 0. Actually, on the worksheet, I think there might be one with infinity, so let me just check. No, I guess they're all 0. So limit as x approaches 0 of, let's say, sine 3x over 24x. So if we did this out, we'd say sine 3x over 3x is what we need. We'd have to multiply the 3 by 8 to get 24, so we put 8 top and bottom. Nope, sorry, just on the bottom. All right, because if we multiply it together, then we have sine 3x over 24x. So then this is 1 times 1/8. The answer is 1/8. So you really are just trying to figure out how you can make an equivalent expression to this that has the same top and bottom, so you can get that simplified to 1. However, you can write that equivalent expression using multiplication or division. That's really what you want to focus on. So writing that equivalent expression and then doing the work to show what the value is.